I smell you hobbits as you come back to Pocket Ronnie.
Okay, we are isolating one variable. Isolating means get it by itself. Okay, so if you look at 15a12, we're solving for pi. It's important to know what you're solving for because you look at this equation, b equals 2 pi rh. Since we're solving for pi, the idea is to isolate pi. In other words, you want pi on one side of the equal sign and everything else on the other side. So when you solve for pi, pi is the only thing on one side of the equal sign and everything else is on the other side. So when you have 2 pi rh, what operation is being implied? Multiplication. 2 times pi times r times h. So we need to get rid of the 2, the r, and the h in order for pi to be all by itself. Well, if all of these things are being multiplied, you need to do exactly the opposite to get rid of them. The opposite of multiplication is division. So we divide by 2, we divide by r, we divide by h. So you can see the 2's cancel, the r's cancel, the h's cancel. Whatever you do to one side, you have to do the other side. If you're going to divide this side by 2rh, you have to divide the left side by 2rh. So now the only thing left over here is pi, and it doesn't matter if pi is on the right or the left, and then b over 2rh, and then that is it. That 2 is in the denominator. So, and that would be your final answer. Pi equals b over 2 times r times h. So, looking at 15a number 11, it wants us to solve for x. So again, that means we need to get x on one side of the equal sign and everything else on the other side. So, looking at this equation, the thing that would be the easiest to move first would be the y. It's being added to this side. So you want to subtract it to the other side. Usually you're going to do your adding and subtracting stuff over first, then you'll do your dividing stuff. So y's go away here. You can't combine r's to y, so you just say r minus y equals 2/3 x. Now from this point, there's a lot of different ways you can do this. So you can either multiply by the reciprocal, 3 times 3 over 2 times this, and they cancel, and you multiply this by the reciprocal. Or you can go through the process of getting rid of the fraction. So if you multiplied everything by 3, let's just say I multiplied this whole side by 3, then I multiplied this by 3. So that means those 3 would cancel, and then you'd have 3 times r minus y equals x, 2x. And then to get rid of the 2, so see we end up with the reciprocal after all. So you see how you end up with the reciprocal over here? And that cancels. So you can just write this as either 3/2 r minus y, or like this whole thing with 2 in the denominator. Same thing, equals x. And that would be your final answer for that. 3/2 times this whole thing, or 3 times r minus y all over 2, it's the same thing. So I wouldn't be too concerned about the forms that they put it in and quote simplifying. So it's just a matter of getting your letters on one side and moving everything else to the other side. Okay, look at 15c, number 3. We are solving for x. In other words, we're trying to get x all by itself and everything else on the other side. Again, there's multiple ways that you can do this problem. For me, if I see a fraction set equal to a fraction, the first thing I usually think about is cross multiplication, especially when what I'm trying to solve for is in the denominator. Okay? So I usually would cross multiply, but you can only cross multiply when you have one fraction set equal to one fraction. And when you cross multiply, you're doing this times this equals this times this. So first you're doing AB times X, and this means A times B times X, set equal to C times Y, C, Y. And remember, we're solving for X, so it means we want to get rid of AB. This is being multiplied, so we need to do the exact opposite, which is divide. If you divide that side by AB, you have to divide this side by AB. Those cancel, and you're just left with X equals CY over AB. Okay, let's look at 15b9. We're solving for b. I just want to say that there is no one way to do these problems. It's not like you say, do this step, now do this step, now do this step. You have to look at each problem and decide how you want to move things around, but letters have the same rule as numbers. So as far as moving things around the equal sign. So just because it's letters, it still has the same rules as working with numbers. So if we're solving for B, we're trying to get B all by itself. So probably the first thing I would do is move the 3 over. There's several different ways you can do this. So I probably would move my 3 over to the other side. It's being added, so I need to subtract it over. So then I subtract 3 over here. That goes away there. Cannot combine C's to 3's. Don't forget your negative. I usually put my negative in the numerator. And then equals C minus 3. Okay? Again, there's several different ways you can do this. You can either think of this as the whole thing is over 1, and you have a fraction set equal to a fraction, and you can cross multiply. Or you can see here that the B is being divided, so we want to do the opposite and multiply it. So if you multiply this side by B, you see your B's would cancel. It means you need to multiply this side by B. Okay, so those go away. So then you have, what you have left is negative A equals C minus 3 times B. And remember, we're solving for B, which means we need to get rid of this whole parentheses. Okay, this whole parentheses is being multiplied to B, so we need to do the opposite of multiplication, which is division. So that whole parentheses needs to be divided away, so it'll cancel. Well, you have to also do that to the other side of the equation. So that goes away. So now you can see you have negative A over C minus 3. And I wouldn't worry too much about what form they have it in. The idea is just to get B over here by itself and everything else on the other side. Alright, let's look at 15b, number 8. We're solving for x. If you look on the right hand side, you have x in both terms. When you have the variable in both terms that you're trying to solve for, it needs to be factored out. Because even if I subtracted xs to the other side and xt, I still have an x. When the variable you are solving for is in two terms, it has to be factored out to free it from all those letters. So on the left, we would still have ts. We factor out our x so we can free it. So then we have left t plus s. So now do you see how I have x all by itself here? I have freed it from these two letters. So now this x is being multiplied to the whole parentheses. So I have to do the opposite of multiplication, which is divide. Divide that whole parentheses to both sides. And those cancel. And then you can see x equals that. Alright, let's go down here to 15.6. We are solving for D. You have a fraction subtracted by a fraction. Just keep up with what's being added or subtracted or multiplied or divide. Okay? So if I'm trying to get everything else on the other side except for D, I'm going to move this fraction to the other side. Okay? So I have to add D over E to both sides. Okay, so over here it goes away. So I have A over B equals D over E. And since I have a fraction set equal to a fraction, then normally what I do is cross multiply. Or if you can either cross multiply and say AE equals BD. You can either do that. So I'm gonna cross multiply, then I'm gonna work it another way. So here we would have AE equals BD, and we're solving for D, so we would need to divide B over. So you can see that D equals AE over B. Okay, let me show you another way. I could have A over B is equal to D over E. E is being divided. That's what I need to get rid of over here because I'm trying to solve for D. I want D all by itself and everything else on the other side. So E is what I need to get rid of. E is being divided. So I need to do the opposite of division, which is multiply. If I multiply this side by E, you can see how my E's are going to cancel because that's like E over 1. If I multiply this side by E, I have to multiply this side by E. Those cancel. And this is like E over 1. So I basically get D equals EA over B, just like I did over here. AE, same thing as EA since multiplication is commutative.